Hello guys, how is it going? This is Mike coming back at you with another video on discrete mathematics. In the previous video, we saw some more sample problems about how do we take the negative of a quantified statement. We saw how the quantifiers change. We saw that we negate the statement form that follows. We saw some examples of how we negate statements or sentences we use in everyday life. And then we revisited converse, inverse, and contrapositive once again. In this video, we're going to talk about statements containing multiple quantifiers. How do these things work? How do we take the negative of these things? In the next video, we'll see some more samples of these things. But this is just a brief, this is just a short introduction to statements with multiple quantifiers. So far we've looked at statements when quantifiers are thrown in. We've looked at statements that only contain one. But there are many facts and many theorems and many definitions in mathematics that contain two and perhaps sometimes even more quantifiers. One such example is the formal definition of the limit of a single variable function at some particular x value a. If you have looked inside of pretty much any Calculus 1 textbook, you will see the formal definition that can be written with two quantifiers. Statements involving two quantifiers come in one of two main forms. We'll talk about the other two cases. Of those two cases, one occurs a little bit, or actually one occurs significantly more than the other, but for the most part, when it comes to mathematical facts and theorems, you'll see things in one of these two forms. So the first one is, for all x in some domain D, there exists a y in the domain capital E such that x and y make p of x comma y true. And the second type of statement that involves two quantifiers that you'll see for the most part is there exists x in D such that for all y in E, x and y make p of x comma y true. Now, a quick note I would like to make here. In my notes here, I just wrote x and y make p of x comma y true. That doesn't necessarily mean that p of x comma y is just one statement or one thing. Capital P here, it could involve a disjunction, a conjunction, a conditional, a biconditional, but it's just some predicate that involves x and y. So first one is for all x in D, there exists y in E. Second one is there exists x in D such that for all y in E. So notice that we have one of each quantifier in these, but the order in which they are placed is not the same. And the order does matter. How would we show that each of these things is true? Well, to show that number one is true, you would allow somebody else to pick any x value from this domain, capital D, that they want. Then, based on that choice, based on their choice of x, you would then choose a y value from the set capital E that would make your predicate p of x comma y true. So number one, when it's for all and then there is, somebody else picks an x value. Based on that x value that they have chosen, you pick a y value such that that x value and that y value will make your predicate true. Number two, there exists x in D such that for all y in E, you have to pick that one right guy x in the domain capital D. You have to pick that one right guy in the domain capital D such that no matter what you pick from set E, such that if you pick any guy in set E, that fixed X value that you chose from D and that random Y value from E will make your predicate true. You can sort of think of X as the master key, if you will, here in the second statement that we are seeing here. X is that one right guy, such that no matter what Y value you pair with it, X and Y will make your predicate true. And it's in the next video that we're going to see some samples of how statements of these two forms look and how they work. So how do we take the negatives of statements with multiple quantifiers? Well, a couple videos back, we said that when it comes to taking the negative of a statement with one quantifier, you change the quantifier to its opposite, and then we take the negative of the, I know I used the word, or I know I used the phrase statement form. The statement form which contains predicates. But mainly we're looking at the statement form that we would have there. So we change the quantifier to its opposite, and then we take the negative of the statement form that is associated with that quantifier. And within that statement form, you have predicates. Well, when your given statement has more than one quantifier, it still works the same way. You still change each quantifier to its opposite, and you take the negative of your statement form. So to say not, for all x in D, there exists y in E such that P of x comma y, that's logically equivalent to there exists x in D such that for all y in E, not P of x comma y. The for all became a there is, and then the there is became a for all. And then we took the negative of our predicate slash statement form, technically more a statement form that will involve predicates. Similarly, for the other statement that had multiple quantifiers, the negation of there exists x in D such that for all y in E, P of x comma y, that's the same as for all x in D, there exists y in E such that not P of x comma y. Existential turns to universal. Universal becomes existential, and then take the negative of your statement form which contains predicates. So as you can see, the order in which the quantifiers are listed in a statement will impact the truth value of the statement if the quantifiers are not the same. We saw for all x in D, there exists y in E such that blank requires one thing to happen. There exists x in D such that for all y in E blank, something else has to happen. But there are cases where we see that the quantifiers are the same. The one that occurs more common is for all x in D and for all y in E, some predicate. You do sometimes see a there exists x in D and there exists y in E such that P of x comma y, but the double universal quantifier is much more commonly seen. If the quantifiers that are being used are the same, then the order in which they're listed will not impact the truth values. Whether you say for all x in D, for all y in E, or for all y in E, for all x in D, does not matter. And just one last quick point. This combination of quantifiers, so the existential, the unique existential, and the universal quantifiers, as well as the variables that we use inside of predicates, the statement forms, the operators, the negation, disjunction, conjunction, conditional, biconditional. All these things combined give us what's known as a language of first order logic. This is just a phrase that you will encounter out there, so I just include it in here, just a fun little thing to throw in at the end. So this is our quick talk on statements with multiple quantifiers. A little bit of a different look for things with multiple quantifiers when it comes to taking the negatives of them. Nothing really new, nothing really out of the ordinary here compared to what we've seen earlier on in this course. So as I said, in the next video, we will be doing some samples. We'll be seeing some real life mathematical instances where we have statements with more than one quantifier. And we'll see how we show that those guys are true. If you have any questions or comments, be sure to drop them in the comments section below. Otherwise, until the next video, take it easy, guys.